My name's Jim Swain, and we're going to talk about tolerance analysis. Now, one thing I want folks to be aware of is there are actually two sets of tools in Inventor. One is a design assistant. There's a tolerance calculator within Inventor. It's been there for quite a while. It's a simple take a look at, stack up, type things in. It's not really the focus of today's webinar, but if there are any questions on it, feel free to enter those, and maybe at the end we could take a quick look at that. What we are going to talk about is tolerance analysis. This is entered through the environments area, not through the design area within Inventor, and is intended to help you clean up your design manufacturing elements before you go into production. So this is the one we're focusing on today. Some key points to understand. I look at this at the same as any other analysis tool. It's to be used at the front end of your design. Find out where you need to put the money for tolerancing and where you don't before you finalize your design. Can it be used at any point? Sure. But you're going to get the best bang for your buck by applying it early and going through your designs and tweaking things and coming up with the most efficient design, most effective design you can. It's a 1D analysis, meaning you're doing a linear design. You're setting up a tolerance chain through a single loop, and it's going to take a look at information along those lines. The software will inform you if it sees that there are effects coming in from other directions, but you're going to get information in a single direction. And what I mean by that will become clear as I show it on the screen. You can set up other analysis for other directions so that you can go and take a look at the different directions coming into play in your design. But a single analysis is looking at from one direction. You can have the software take a look through any constraints and joints that you have in your setup, but you don't have to. Software can go and take a look for mates between faces, insert constraints and such. But maybe you've got a design where there aren't any, or you just don't even want to worry about them. That's fine. You can pick where the relationships are and go ahead and run your analysis based on that. The tolerances that are coming into play are already in your design. There might be in the sketches, might be in the features, or you might be having them come in from model-based definitions. For example, sketch dimensions, the document has some basic overall settings, and then you can override those individual dimensions one by one through your sketch. And I'll show you that in just a few moments. Those default tolerance values might be coming from your template file. You may have set them or reset them at the beginning of the design of an individual piece. You can override any given dimension, tweak it as you need to. Also, what may not be apparent is that these same default tolerances get applied to the feature, such as an extrusion. This is your basic 1-inch long extrusion, but since the dimension was to 2 decimal places, a tolerance of 0.01 was automatically assumed. And then here's an example of part that has model-based definition applied to it. And these values can be brought right into the tolerance analysis as well. All right, now let's actually take a look at the software itself. So here I have a very simple assembly. Fixture holding a series of blocks, and as you can see, there's already a gap right in there. Now, the reason I put this at the angle was nothing more to try and dispel rumors of what might be meant by one dimension. Here, I'm going to look at what's going to be the allowable tolerance and variation in that gap. As I said, I'll go into it from the environments, tolerance analysis, and I'll start a brand new analysis. Now, something just to make note of, I've got this area very large, and it's a bit of a compromise working with this webcast. In a more normal environment, I would go and take this particular window and put it on the secondary monitor. I'm not going to do that today for the sake of this webinar. Okay, so yes, there's a successful run already. That's just making sure you have backup for the webinar. I'll start with a brand new stack up to go through the full workflow. Now, the first part it's looking for, as you can see from the on-screen prompting, is where am I looking for the beginning of the stack up? Well, I'm looking for one side of that gap. Now it's kicked over to the second selection, so I want to pick a face that forms the other side of that gap. I'm now being asked for an annotation plane and a dimension location. Now, here's a case where it found an automatic path through a series of insert constraints that were used to bring these pieces together. It's looking at those faces that are on the insert. So you might notice an insert constraint really is a mate between a pair of circles. Circles define a plane. This is new for the Inventor 2020. If you're running Inventor 2019, insert constraints will not be available to you for automatic selection. Mates between faces will be. And if I didn't want to go that route, I could go and manually select them. I'm going to stay with the automatic one for this piece and then go. So one path was found. I'll tell it that's the one I want to use. Click the OK. And here you can see on the screen what elements are making up this loop. And now I'm going to sacrifice some screen again to show you what's going on in the tolerance analysis. So each of these has been identified with a certain tolerance. What I want to do now is go to the end of this chain, and down here in the stack up, I've got a choice at the bottom that says, what is my objective? Right now everything's looking really good. I've got a show of anything from 28 thousandths to 72 thousandths clearance. Life is good. But if I decide that for whatever reasons I really want my available gap to be a 1/16 of an inch, life is not so good. Now you can see where my current tolerance is centered about the, about that 050 as well, leaving much smaller area. Could I still put these together? Yes, but if my goal is greater than or equal to a 1/16 of an inch, I don't have what I need. What I have the ability to do then is to go back, change tolerance values if warranted, and see the results of the analysis. For example, if I just change this one to 1/1000th of an inch, you can see a little bit of a shift in the whole piece. Also, I can take a look down here at the contributions, and I can see that, wow, working with the individual blocks probably was not where I'm going to get the best return on my investment. Really, what I would be better off doing is either taking this down, maybe improving some manufacturing techniques here, or upping the value. And this is what I mean by using this as a front-end tool. May not obviously be able to do that if I don't go down that route. Playing around with this, tightening the value, in fact, hurt me here. I may have just wasted money for no good reason. And what might have been a, I don't know, obvious is a bad phrase for it, but something that would have been the first pass, oh, just tighten up the tolerance, life will get better. No, that's not the problem here. So that's the basic flow. As I said, this is a front-end tool. So I want to set up my goals early and then see how things go. The other thing I'll point out is that this is working on what would be called a worst case analysis. Well, if I'm doing enough of these, maybe I can assume that there'll be some statistical information coming into play, and I won't always get the worst case every time, all the time. Here you can see a bell curve going on in play, and up in the settings, there's some assumed values that come into play for the statistical modeling method. Now, where I used to work, we always stayed with worst case. Maybe in your industry, you're putting together a large number of pieces with random variations coming into play, so you could assume that a statistical process might come into play, and therefore let's assume that. I've heard discussions, arguments more the other way, that people will go and set up the tools to make the individual pieces to start at one end of the tolerance range, and then as wear occurs, the pieces will grow to the other end of the tolerance range, so the worst case is the right way to go. That's really a corporate decision. This is a tool to help me decide whether I'm going to meet my goals. That goal itself is a corporate decision. All right, now let's take a look at a different analysis, very similar looking pieces, but I'm going to step through this one in the manual methods to give you a chance to take a look and see how that goes. Again, I'll make a new stack up. Selection 1, it's asking for where is the beginning of it. There we go. Selection 2, and I'm waiting my machine set up for the 2-second delay to be select other. There we go. We've got the two pieces, annotation plane. Notice in this case, first of all, there was no gap. That 0 showed up there briefly. Second, I don't have any of the automatic selection taking place. It's asking me to pick the components, and I'm going to pick those in the order that's going to build my tolerance chain. This is important. You want to pick them in the order. So next one's that. Notice the software is changing visibility of those components as I go. I can't pick the ones that have been made phantom there. There, I picked all the way through my chain. I picked the pieces in the order. I want to look at the tolerance values, and now it's asking me to start selecting faces between those components where they made up. So here I'll pick that face. The software is automatically doing this swap of the pieces and their visibility. So picking the next one, and I'm working my way down the chain. Again, where are the mating faces? So that's the mating face going to that one. That's the last I needed because it already knew about this initial mating face. So it came up with 8 out of a total of 8 interfaces. So we're good there. I'll go ahead and hit OK. And again, it's taking a look at the tolerances. And here you can see these pieces have a much larger spread, so that initially I have 0 clearance, and I'm going to need to open that up, and with the way things are looking here, I might have to go all the way up to 1/10 of an inch for possible clearance on these. Again, if my goal is more to pass a statistical sampling, then I could go down and start looking at it from that point of view as well. 2 very simple examples, one showing the automatic chain selection, the other one showing a manual piece. So I'll back out of here, and we'll go into a more complex piece. I'm going to go and take a look at this gearbox, and I'm going to look at it from 2 different methods. First one, again, we'll be taking a look at some automatic mates being selected. Before I go into the actual analysis, please note that I went and set up and view representation to help me so I can get in and pick those. This would be very difficult to work in this example if I was picking through the case trying to grab the appropriate faces. So I set up a view representation. The other thing I did before I created this view representation, though I guess it could have been done afterwards, is in my options, I went and said for assemblies, go ahead and section all parts. Therefore, items that are coming from the content center, such as these bearings and these fasteners, are allowed to be sectioned as well. Makes it a lot easier to pick what's going on. I need to see what I'm going to do before I go and do it. So once again, environments, tolerance analysis. And yes, as you can see, I've run one already just to be sure. We're going to ignore that for now. And I'm going to go and make a new stack up. So here, select the face, edge, vertex, whatever at the start of the stack up. For this one, I'm going to come in and pick the face on this gear, because you might notice this sign's got some, let's just say, it challenges ahead of it. That gear is being pushed on by this cover. Also, that bearing cap's getting in there and working into that. For this analysis, let's just take a look at the case cover. So I pick those two as the faces where I'm worried about things. It's now asking for the annotation plane. I'll take advantage of the XY plane being the center of this. Makes life a lot easier. And I'll place this up ahead. All right. Again, my options here are to grab existing constraints, joints, or manually select. I'm staying with the automatic, and have found a single path through these various pieces. I'll have an example in just a moment where you have to pick and choose between the possible chains. You still have to choose it, otherwise you won't get the OK. Now, because I selected all those, all that information was populated, and again, my results are based on the default tolerances. Also, please be aware that this is coming up in the values for my document settings. So if I were to go to, that's grayed out because I'm still in the analysis, I could go and change my units here before I go into the analysis to be able to look at it in metric or English, what have you. So maybe my tolerance needs to be upped a little bit. Maybe that overall case, whoops, that's not what I was looking for. I was looking for the 10.6. Here we go. Maybe that case tolerance saying it's plus or minus 0 is a bit unrealistic, but I can start putting in some values on different pieces as we go through this. Some pieces are coming from maybe a more precise manufacturing process. But as I go through this, what's going on down at the bottom is these stack up is getting adjusted as I go through and make my changes. And now what I've got is probably a fairly nasty situation. Yes, that's quite a bit of a variation. And if my goal is to have, maybe a minimum of a ½ millimeter, I am definitely not going to be meeting it. And it looks like with that plus or minus 19 millimeters, there was probably a typo that came in play there as well when I was typing in some tolerance values. Yeah, maybe not. So here we've got an issue. Now, what are we going to do to correct it? This is where you need to take a step back. This is a predictive tool. This is a front-end tool. What could go wrong? Now let's adjust it. Do we need to, A, put some clearance in there? You can go to your own conclusion there. My answer is yes, that it's just too darn tight. Also, is my Tolerance availability for the gasket going to be an issue? Maybe, so on. Again, very much a predictive tool. To take another look at this and maybe even make that clear, let's take a look at a version of this that didn't have any. Whoops. Let's open up the right, there we go, the right assembly. You might notice from the name, this one doesn't have any constraints. And to go through that same process manually, setting up a tolerance. Same piece, I've got that same view representation already in place. So go ahead and start another new one. All right, same basic process you saw before. So that's my one face of interest. Come around and look for the appropriate face. And I'm going to pause there for the 2 seconds because that's what I have my application options set to. There we go. Annotation plane. Again, we'll go with the XY plane. And I'll drop this down there. Yes, there's already one in place. And here, since there weren't any existing assembly constraints or joints, it's not even an option. I have to go and select things right off the bat. But I'm going to be prompted. Select the component that mates with the output gear, and the output gear has been grayed, just like it was in that simple example earlier. So that shaft mates up with the output gear. What's next in the string as far as the shaft is concerned? That retaining ring. Then that spacer, then that bearing, then that case. Now this is probably the biggest challenge with the software is I want to be careful on picking things in the proper order. I said that before. So here again, I'm pausing. On my machine, I still have that select other delay set at 2 seconds. I recommend shortening that, but I leave mine at that 2 seconds for the sake of training. Okay, so then I grab the gasket, I grab the case cover. Now it's back to select where things are meeting. Where's the drive shaft meet the that output gear? Well, on the output gear, it's there and there. All right, now where does the drive shaft meet with that ring? What I can say here is it's going to be inside of that retaining ring groove. It's going to push on here. I could have a separate analysis then looking if I was looking at the other side of that retaining ring in the groove. I'm working down through one side on this. Again, that would be a second analysis. Graphically, it's prompting me as I go along to select the appropriate faces. The 3D mouse is doing a nice job of allowing me to spin back and forth quickly and easily. You can use your own methods. All right, 14 of 14 mating faces were selected. Did I get it right, or do I have to kill this and go back and select them again? And here again, we're building it. Now this time, I'm starting off with almost 1 millimeter of clearance, and allowable variation is not bad at all. Is it within my goal? I haven't put in my objective yet, so I don't know. If my goal's at 0.5 millimeter again, no. Now I have to go back and start looking at where I can tighten up tolerances. Again, this is predictive. This is where I'm going to start looking at the trade-off between a higher tolerance and a manufacturability of that component. So that is the basic workflow of the software, using this at the front end and allowing you to take a little bit of time to see whether this is going to work for your design, and more importantly, working for your design goals. depending on my goal, if I'm willing to say that statistically the odds of getting the worst case pieces that stack up all against me at the same time, then I'm good. If I'm not willing to say that, I need to stay with the worst case, maybe because my overall volume is low enough that I just don't want to go statistical, then I need to do some work, maybe spending some more money on secondary finishing operations, or for higher precision pieces in the first place, or flat out opening up some gaps which might have a downside from a performance point of view. So, to get back to summary, oops, of course the wrong one. Let's take a look at the overall workflow, and I see we still have a few moments for any questions. So my workflow, I hopefully have made this clear, is you need to know what you're looking for before you start looking for it. This is the same for any analysis in my mind. I don't care if it's computational fluid dynamics, stress analysis, what have you. You need to know what you're looking for before you start looking for it. Also, this is going to give you information that's a 1D only. There was a piece in there. Here's an example of a piece that's bolted up. Oops, wrong button. There we go. And it's loading some results there where these were bolted together off of where the plane of interest. This was looking at a gap between some spacers in there. There you can see the gap right in this area. Well, the bolts are not in that plane. Therefore, there's some possible three-dimensional rocking take place. That's what the yellow warning symbol is indicating to me. This is a one-dimensional tool. Could I use it in that other piece? Certainly. And if there are no questions, I'll show that workflow on that caster in just a minute. But bear in mind how this should be used the right way. Before I go into the analysis, make it so I can see what's going on. Finally, run the analysis and then take a look at your results. The goal for this is to be smart in your decision making. Is the design going to work as you have it? If not, where should you spend your effort? Where should you spend your resources, which includes money, to make things work? Once you have that, then proceed with putting your design out into the world. So at this point, let's see if there are any questions. I'm not seeing any at this point. I'll give a moment if folks want to put in questions, and the way I'll do that is I'll run through that analysis, do another one on this particular beast. So I will start a brand new stack up. As I said, I'm going to go for either side between those two pieces. Annotation plane. XY still works on this piece. Now, 4 paths were found here. And as I mentioned, these are the various bolt-up combinations. And it's up to me to pick and choose, but none of them are in the plane of the tolerance analysis. Therefore, there's possibility of 3D effects coming into play. And there you can see it working through the mates and coming up the chain. Again, here, what I would need to do is go back and tweak these tolerances to get what I need for my available gap in this piece. I'm still not showing any questions, so at this point, if anything else comes up, my contact information is available off of Synergis website, but feel free to email me, jim.swain@synergis.com. And I'd like to thank you for your time.